Hello, everybody. Welcome to the very first notes for homework session that we have for physical science. Hopefully, you're able to get on the wiki with no problems and find the link. So, we're going to get started. Today's notes are going to be on physical and chemical properties. So, next week, we're going to start talking about what that is and what the difference is. We're going to have some examples and some days where we do some pretty cool stuff. So before you actually start taking notes, I want to show you this way of taking notes. It's called Cornell notes. So if you are in Miss Gwen Ford's class, or if you've done this before in middle school, this is an example. So we have the topic at the top, the name, class period, and date on the side. And then you don't have to do the essential question, but if you wanted to make an essential question, it would be kind of the whole point, which is it's kind of a question form of the topic. So you don't have to do the essential question if you want. But the main point is here at the bottom. So we're going to draw a line down the left side of the paper, and you will have a very small column for questions, and then on the other side it will say notes. So basically what you want to do is, as you're taking notes and writing down definitions or working out problems, any questions that you have that I can't answer in this PowerPoint, I want you to write them down so that when you get to class, you'll be able to ask those questions and you won't forget what they were. All right, so it should be pretty easy. All right, so first of all, before we can talk about physical or chemical properties, we need to know, first of all, what is matter, because matter is what has physical and chemical properties. So if we don't know what matter is, it's going to be hard to figure those out. So matter is anything that has mass and takes up space. Now, you should remember from last week that mass is usually measured in grams. Could be kilograms, could be milligrams, but some kind of gram, and it's measured in on a balance. All right, so a balance can measure mass. So the mass is the amount of matter in something. So your mass is how much stuff is in you. All right, whether that's blood, bones, organs, your brain, air, all of the things that are inside of you that take up space contributes to your mass. All right, now your volume is the amount of space you take up. So this week we're talking about volume. We're going to be calculating volume. Depending on when you're listening to this, we might have already done it or not. So volume is the amount of space you take up or an object takes up. So let's look at the bottom part. Which of the following is matter? All right, and I just want you to quiz yourself while you're taking notes here. So a boat, a blanket, a baby. All right, take a minute. Think about which one you think is matter, or is there more than one? Okay, so hopefully you know that all of these are matter, because a boat, a blanket, and a baby all have mass. They all have stuff in them, and they take up space, right? You can't just put a boat in your pocket, because a boat takes up quite a bit of space. All right, a blanket cannot fit in an envelope, because a blanket takes up more space than that. So each one of these things has a certain amount of space that it takes up. All right. Now, one important thing about matter is that it has properties. Properties is like the scientific word for characteristic. So if you know what a characteristic is, like a characteristic of my house is that it's made of brick. All right. So a property is the same thing as a characteristic. It's a characteristic of a substance that can be observed. So anything that you can see, hear, feel, or taste, that is a property of that object. So Sour Patch Kids, the candy, The properties would be that it is sour and then it turns sweet. It's kind of rough when you feel it. And it's sticky when you're chewing on it. All right. They're colorful. So anything that you can observe about Sour Patch Kids would be the properties of Sour Patch Kids. So you can do that with any object. All right. You can look around the room that you're in right now, pick an object, and anything that you can say about that object is a property. Okay. So now I want you to take a second. You don't need to write this down, but it's just to practice figuring out what a property is or what kinds of things have certain properties. So I want you to think of some properties of a thunderstorm, then an apple, and then a kitten. All of these should have very different properties, but they also might have a couple of the same properties. So go ahead, I'm going to take a second and pause, and I want you to figure out at least a few things about a thunderstorm, an apple, and a kitten. All right, good. So you can pause if you haven't had time to think about all of them, and then you can press play again when you're ready. So a thunderstorm, some things that come to my mind is that it's loud. It is often rainy and windy. Sometimes thunderstorms happen when it's cold outside. Sometimes they happen when it's hot outside. So all of those would be properties of a thunderstorm, all right, because it's characteristics. Now, an apple. Apples are round. They can be red or green or yellow. They can be crunchy. They are sour sometimes sweet, juicy. So all of those are properties of an apple. All right, you could talk about the size. It fits in your hand, in the palm of your hand. So that's a property of an apple. All right. Now, lastly, a kitten. Things that come to my mind is that they're soft, they're furry, they're small, they are cute. I guess you could use cute as a property. And they make tiny cat sounds, tiny kitten sounds. All right, so anything about a kitten that you know of is a property of a kitten. So hopefully now you kind of understand exactly what we mean when we say the word property, because that's going to be a word that we use all year long. So at any point in class, if you're not sure what we mean when we say property, you need to make sure you let us know right away so that you will not get behind. All right, so now we're going to talk about physical properties and chemical properties. So the first one is physical properties, and there are a lot more physical properties than there are chemical properties. So a physical property is something that can be observed without changing the substance itself. So let's say this kind of goes along with physical change, which we're going to talk about next week. But a physical property would be something that has to do with the identity of that substance. So the fact that an apple is round, that's a physical property. Because if you saw an apple that was a square or a triangle, you might not be sure that it was an apple because it doesn't look like an apple. All right. The fact that a thunderstorm is loud. All right. If someone told you it was thundering but you couldn't hear it, you probably wouldn't believe them because a characteristic of thunder is that it's loud. All right. So some of the examples that we're going to talk about in science are listed below. So luster, whether it's shiny or not shiny. All right. That's a physical property. So a physical property of metal is that it is shiny. However, a physical property of cardboard is that it is not shiny. It does not have luster. Okay. The next one is malleability, which is the ability for something to be hammered into a thin sheet. So what you could do, you could go in your kitchen and get some aluminum foil and roll it up into a ball. All right. Now, what you have is still aluminum foil, correct? All right, but it's in a different shape. All right, so you could take a hammer or something heavy, and you could start hammering the aluminum foil and make it flat. All right, and it's still going to be aluminum foil. So malleability is a physical property. All right, because even if we hammer something and it changes shape, it would still be the same thing. All right, so it doesn't matter whether you hammer aluminum foil, whether you roll it up in a ball, it's malleable because it can be bent, but no matter what shape it's in, it's still aluminum foil. Okay? Now, ductility is another one, which is the ability to be stretched into a wire. So there are things that are ductile and things that are not ductile. All right? And that's a physical property because even if you stretch it into a wire, it doesn't change what the object is. All right? It's still the same object. All right. Now, some on the side that are important are melting point, boiling point, density, and solubility. So we're going to talk about all of these in a second, but I'm going to go ahead and explain solubility because we're not going to talk about that one. So solubility is the ability of a substance to be dissolved into another substance. So sugar has a high solubility when it's placed into warm water. All right. So if you make some sweet tea, you make the tea first and it's warm and you add the sugar, it's going to dissolve really quickly, which makes it sweet tea. All right. So that is a physical property, but the sugar is still in there. It doesn't change the fact that it's sugar. So it's a physical property. All right. Now, melting point and boiling point are some of the important physical properties we'll be talking about for a long time, not just this week or next week. So melting point is the temperature at which a substance changes from a solid to a liquid at a given pressure. And for water, the melting point of water is 0 degrees Celsius. Now remember, that's not 0 degrees Fahrenheit. So when we say 0 degrees Celsius, that would equal about 32 degrees Fahrenheit, which is why when we're looking for a snow day and it's supposed to be really cold and it's raining, if it's below 32 degrees, it's a much better chance of us to get out of school because of snow. Because if it's less than 32 degrees Fahrenheit, then the ice will not melt. But if it's more than 32 degrees Fahrenheit, the ice is going to melt. All right, so these measurements are in Celsius, but you know, when we're looking at the news, we're looking at Fahrenheit. Now, the boiling point is the temperature at which a substance changes from a liquid to a gas at a given pressure. So when you put a pot on the stove and you're boiling water to put noodles or rice or something in there, the water has to get to 100 degrees Celsius, which equals about 212 degrees Fahrenheit, before it starts bubbling and boiling. So you know that when you put the water on the stove, it doesn't start boiling right away unless you've had the stove turned on for a while. All right? If you turn the stove on, it's not going to start bubbling right away. It has to warm up to a certain temperature. All right. Now, density is a really important one, and we're going to spend a whole day next week talking about density. But density is also super cool, and there's a lot of neat things you can do to look at density. So density is the amount of mass per unit of volume. So basically, we know we can measure mass in grams, and we know one way we can measure volume is in milliliters. So if you are asking how many grams of something is in each milliliter of that substance, that's the density. So you can have a lot of particles in one unit, or you can have a few, and that's why density is going to change from object to object. For example, if you look at a brick is very dense. It has a lot of particles in each piece of the brick. You could break any part of the brick and it would still have a lot of particles. It's like solid and heavy. All right, that's because it has a lot of matter in there and it has a lot of mass. So a brick would be more dense than a feather because a feather's particles are spread out. They're not as compact. And so they would have different densities. All right, with the brick being the more dense probably. All right, density can be used to identify a substance and tell whether it will sink or float. And the way we tell if it's going to sink or float is we compare it to the density of water. So the density of water is 1 gram per milliliter. So if a substance has a density greater than 1 gram per milliliter, then it is more dense than water and it will sink. If a substance or an object has a density that is less than 1.0 grams per milliliters, then it is less dense than water and it will float. So that is one of the things we'll be doing in class, is looking at things that float and sink. All right, we're going to go over this together, I promise, but it's good to go ahead and get familiar with the idea of the calculations. So the way we calculate density is we calculate mass divided by volume. So when you have the mass and the volume of a substance, you can divide them and get the density. So you need to keep in mind the formula. An easy way to say it is D equals M over V. Okay? So here's an example. A cube has a mass of 2.8 grams and occupies a volume of 3.67 milliliters. Would this object float or sink in water? So our mass is 2.8 grams. Our volume is 3.67 milliliters, which means to find the density, we divide 2.8 grams divided by 3.67 milliliters, and we should get 0.76 grams per milliliter. Now, if we look at that, 0.76 is less than 1. So because the density is less than the density of water, this object should float. Okay? So hopefully that makes a little bit of sense to you. All right, here's one more example on density, and then we're going to talk about chemical changes or chemical properties. So this example says a liquid has a mass of 25.6 grams and a volume of 31.6 milliliters. Use the table below to identify the substance. So remember, we can identify what the substance is if we know its density and what the density should be of that substance. So our liquid has a mass of 25.6 grams. It has a volume of 31.6 milliliters. So we divide 25.6 by 31.6, and we get 0.81 grams per milliliter. And if we look on this chart in the green here on the right-hand side, you have mercury, water, and ethanol. And it gives each of their densities. And all we have to do is compare our answer to this chart to see which substance we are looking at. And since we got 0.81 and the density of ethanol is 0.81, we know that the liquid they're talking about in the problem is ethanol. Okay, so hopefully that makes sense to you. If it does not, this would be a great time to write some questions on the left-hand side of your Cornell notes so that when we talk about it in class, you know what it was that you had a question about. All right, lastly, we're talking about chemical properties. A chemical property is something that can only be observed by changing the identity of the substance. So let's go back to our apple. Our apple is round, it is red possibly, and it is firm. All right, so those are all things we know just by looking at it. We don't have to do anything to the apple in order to see that, right? You can see that, and then the apple is still the same. So for a chemical property, there are things that you have to do something to the substance to see what its chemical properties are. So flammability is an example, which is the ability to burn or catch on fire. So if we wanted to know if an apple was flammable, we can't just look at it or feel it to see that. We have to actually try to set it on fire. All right? So if we light a match and we hold it against an apple and it immediately lights on fire, then we know it's pretty flammable. If we hold the match up to the apple and it just, maybe it doesn't catch on fire, or, it's really slow to catch on fire, excuse me, then we know it's not very flammable. All right, the second example is the ability to rust. So if we want to know if something can rust, we need to what? How do things rust? We need to get it out in the water, in the rain, and we have to expose it to water and oxygen so that we can see if it rusts, okay? So if you're looking at a bike, bikes usually rust if you leave them out in the rain and the weather for very long. So if you're looking at a bicycle and you don't know whether or not it will rust, you actually have to try and see. You have to put it under those conditions to see if it will rust. You're not going to know if you're at Walmart looking in the bike section. You're not going to know if it's going to rust just by looking at it. You actually have to do the things it would take to become rusty to see. All right? And the last thing is reactivity to other substances. You won't know if something reacts to something else unless you put them together. So, sorry guys. So if we go back to our, let's go back to our apple, I guess that's a good example. So if we want to know if an apple will react when we put vinegar on it, we have to actually put vinegar on it. We can't just look at an apple and know whether it's going to react to vinegar. So if we want to know if a substance is reactive to another substance, we have to put them together and see what happens. And that will tell us whether it's reactive or not reactive. All right, so hopefully that makes sense. Feel free to rewind, to pause, to go back, and definitely try to find at least one question that you have that maybe I didn't explain it as well as you would have liked, or maybe my explanation was a little confusing to you. So have those questions ready in class so that we can get to the bottom of it and you can understand this as completely as possible. Good night, good afternoon, or good morning, whenever you're watching this, and I will see you later. These notes are due first thing in class on Monday. They will be checked during the due now. Bye.